Okay, but I think let's start. The current and future challenges of high-strength steels with hydrogen. This is so big headline that I can more or less thought what I like, and but the point is, I think why to discuss today of this is that we are now taking step from current situation that is more or less what we have done today in this situation is steel development. The next step that is partly or we start going to the hydrogen society or more or less that. And what is the role of steel on that point? So I will now explain, or maybe this is more or less the discussion based on that. So let's go. So first to go on the current situation. I have to say that a little bit disappointed for myself, but because I have to start this as a banana diagram. But let's say, or let's start about that still. If you think about the hydrogen at high strength steel, we can divide in two pieces or in three pieces in what I have done here. The first case is in high strength steel, that is more or less starting when you talk about the hydrogen in about 500 megapascal tensile strength, and that is main reason is that then you probably have some problems in hydrogen. I think in lower strength it's not so big problem anymore, but you can see it. There are a lot of research still focusing on that area. Then in ultra high strength steel, that can be divided over 700 megapascal steel, but when you're talking about the hydrogen, the limit is more or less 1000, and it's quite problematic after that. We are talking about then more or less the levels of hydrogen is 1 ppm or less of that. Well, we can control that. We know the traps element. We know the different traps. We can use different grain boundaries, dislocations, precipitation, or also, and so we know that the microstructural effects. And that is more or less what we are right now. We know that situation. So the point is, high strength steel or ultra high strength steel and the steel and the hydrogen is a little bit problematic combination. In lower strength level, let's say this 500, what I showed is talking about typically is a hydrogen inducing cracking. This well-known problem, we know that, especially in marine and offshore industry. So it's based on corrosion. It's based on corrosion reactions. So we get with the help of this corrosion reaction, we get hydrogen in the steel, and we get a lot of problems that can be even have a blister or in gas in different segregation or boundaries as well. So we know that this is the possibility, and I think this is more or less controllable today. But when talking about higher strength and hydrogen embrittlement, there is a more or less, as discussed already, is the limit is about 1000. So this figure is based on literature survey, and if you think about in overall, there are a lot of deviation in that way. We can have a somehow limited curves that there is no harm when talking about the threshold of hydrogen content less than 10 ppm. So you have noticed that this is the idea of this figure. I just write the curves at the banana curve, so this is not so let's say, scientific point of view, but we can see the situation what it is. We know that the microstructure, for example, that microstructure effects, like high manganese steel, is quite resistant on hydrogen, but and we also know that there is a microstructural changes, and then hydrogen embrittlement can divide quite a lot. So this is more or less what I like to show about this figure. The other thing is that when we are using really high strength steel, we are then talking about the hydrogen content less than 1 ppm. Probably we hear some comments about that as well today's presentation. Okay, then let's start and go on future challenges and what that actually mean. So this presentation, or in this case, I take that role that the next step will be higher hydrogen society. So we mean that the energy source of the future is hydrogen. What that means in steel point of view, what kind of steel we have to take into account, what is the role of these? It's quite clear that steel is part of the future and a part of the future society as well. This is more or less clear. But I think the biggest change in steel point of view will come here on the transportation areas, maybe also industry. We have heard about these hybrid projects and overall, and also some other things. But the point is that we do not have clearly understand what is the material problems or the challenges when we go on that level, the use of hydrogen. We have to think about the level of strength level and what is the role of hydrogen in high strength steels. This is an example. Just show what we have done in this year, until now. So the CO2 emissions has decreased, let's say, about half during 10 years. And the reason for that is more or less on motor development, but also so that we have possible to develop strength of the steel so that the mass or the weight of the vehicles will go down. So we have to save energy. This same kind of situation will continue. It's definitely so that until we go in or toward hydrogen society, it's more or less clear that we still have to save energy. And the easiest way or the best way to do that is to using high strength steel. It doesn't go anywhere. So when thinking about the steels in overall, again, other banana diagram, but there are a lot of that in internet. So what is done? We have developed first, second, and third advanced high strength steel. So it's easy to see that the next one is fourth. This is quite clear. But what it will be, where we want to go. I think what you can see here already is that this original banana diagram is now changing. And I think in my mind there is not so clear role anymore in tensile strength elongation based curve. There is a usability that comes on whatever that usability means. In my mind it means much more other things than that weldability or bendability or machinability or so. It means that we can use it safely and it's sustainable as well. So it means that when we are developing strength of the steel, we have to understand the usability of that more and more. And that means that the steels coming unique, maybe more complex, and they have developed in some specific applications. So based on that idea, when thinking about this hydrogen resistant as well, so it means in that point of view, so we have to understand what is the behavior of hydrogen, what is the role of that in different applications, what is the stress level of this application, and how the steels behavior on that way. What we have to do to develop the steel in that specific applications. So we as a metallurgist, maybe this is a little bit pessimistic figure, but we know that there are a lot of challenges where the hydrogen can be and where the damages can happen. So there are possibilities really much. So in summary, in this case, when we want to go here in higher strength steel and better usability, I think there is no clear solutions yet for the use of ultra high strength steel application if the hydrogen embrittlement is possible. So that is more or less, in my point of view,